The simulation shows the sequential motion of a negatively charged particle in a homogeneous electric and magnetic field. The homogeneous electric field is formed by applying a potential difference V between two parallel metal plates spaced L apart. In the help section, the detailed theory of the simulation is mentioned. The parameter V indicates the potential difference between the plates. The parameter B indicates the intensity of the magnetic field. The parameter M indicates the mass of the particle. The parameter Q indicates the electric charge of the particle. The parameter SR, simulation rate, denotes the rate of motion simulation. We observe the particle's motion experiencing linear acceleration in the electric field and circular motion in the magnetic field. The results table displays equations and calculates the electric field intensity, the force exerted by the electric field, the acceleration, velocity, and displacement in the electric field, the force from the magnetic field, and also the radius of the particle's circular trajectory. We can hide the vector quantities of the phenomenon, pause the simulation, and also reset the simulation to its initial environment. We can choose various combinations of parameters and study the simulation. Finally, in the problems section, problems corresponding to the simulation are proposed. You can solve these problems and verify the correctness of the results using the simulation.